Well, let's have a talk about potholes on the State Highway Network. Potholes have been in the news a bit recently, and they can tend to become a bit of a political football. But it's important to note that potholes forming in the road are really just an indication of something deeper wrong with the road. It's also really interesting, as we see these debates going on, that the issue of potholes is getting used as an indication of the overall wider condition of the State Highway Network. And that feeds into a wider ideological debate going on in our countries about whether we should be using roads, trucks and cars for most of our transport solutions, or whether we should be transitioning to other transport solutions such as rail, mass rapid transit, walking and cycling. So what causes potholes to form? Predominantly it's caused by water entering the pavement. In some parts of the world, freeze-thaw effects are very common in causing potholes. Now, most of our roads in New Zealand and Australia are not subject to freeze-thaw effects, although obviously some regions are. But the root cause, being the water entering the pavement, is still the primary cause of potholes. So let's understand a little bit how the roads are made. In New Zealand and Australia, we mostly use thin surface flexible pavements. That is, a thin surface of bitumen and stone as a sealing and wearing course placed over a construction layer of compacted aggregates. Now we do this because it is a very effective, cost-effective and long-life method of building roads when done correctly. The other types of pavements that are commonly used, such as rigid pavements, concrete pavements and deep lift asphalt pavements, these are very effective as well. They can last for decades without major maintenance, but they are a lot more expensive. So we typically only use them on motorways and freeways. What that means is thin surface flexible pavements are pretty much where we're at for the bulk of our state highway network for the foreseeable future. Now let's have a talk about potholes forming in these thin surface flexible pavements. So as we mentioned, the surface is some combination of stone and bitumen. That bitumen is a very ductile product, it's very flexible, but over time, as it's subject to the elements, hot and cold, sun, rain, and of course the constant barrage of traffic, heavy vehicles in particular, the bitumen will fatigue and age. And then it becomes susceptible to micro cracks forming, environmental cracking we call it, or fatigue cracking. That allows the water in through the surface, it then moistens or in some cases saturates the actual pavement layers and weakens them. Now with the continual pounding of those heavy vehicles, the surface can delaminate, and once it's delaminated it will start flicking out and the pavement layers underneath will start coming out as well. And of course, as soon as that pothole starts to form, the water will collect there and the degradation of the pavement will accelerate. Another enemy of the pavement is rutting. As soon as a rut forms, the water tends to sit there, and then not only do we get gravity fed water through the pavement, but we get it driven in by the passage of the wheels. So what can we do about it? There are a number of things we can do to reduce the ingress of water into a pavement and therefore reduce potholes. The first thing and the most simple thing we can do is clear out the drainage on the side of the roads, make sure the water can get away, and make sure water is not seeping in from the sides. The next thing we need to do is make sure we've got an effective seal over the top, and also, this goes back to the construction of the road, make sure we've got adequate strength in the actual pavement layers. If we are constructing a new road, there are a number of things that we can actually do to significantly increase the life of the pavement. When we're placing the seal coat down, we can use a membrane sealing layer underneath the surfacing to actually prevent that water ingress. For chip seal pavements, we have products like the Pave Seal, which is a non-woven needle punch geotextile. As it gets laid down, it gets impregnated with bitumen and becomes impervious, but it's still flexible. Now that can move with the pavement, but prevent water from coming down through those cracks. For a very high volume, high trafficked chip seal surface, we can also use a chip seal grid. Now in addition to the sealing function that I've just described, it also has the additional reinforcement function of high tenacity fibres, preventing those cracks from forming in the first place. If we're using an asphalt surface, such as a 30 to 50 mil surfacing layer, we have some very effective products such as the Husker Hacklet asphalt reinforcement grid, which not only stops cracks from forming in the asphalt layer, but prevents reflective cracking from coming up from the pavement below. These are products that can be added at very little cost during the construction of the road and add a huge amount of life into the pavement. So in summary, we want to make sure we've got a really good seal coat. We want to make sure we've got a really good foundation layer, and we want to clean out the drainage. Now, in the situation, if we're actually constructing or rehabilitating a road right down to the pavement layers, we can also add in stabilisation grids at the base. We have products such as the DuraGrid X grids and the 10X 3DT products, which have been proven in large-scale tests to stiffen the aggregate and or reduce rutting in the pavement layers, which once again increases the pavement life. Remembering that ruts forming in the pavement, which water can sit in, is one of the things that accelerates potholes forming. And just a word before we go, while we're talking about road network maintenance, we get a lot of comment and we see a lot of chatter in the media about the number of road cones on the road. Well, just bear in mind that when there's road cones out there, someone's fixing the potholes. So that's a shout out for the road workers.